Okay, question number 10. An institute conducted a clinical trial of its method for gender selection. The results showed that 188 of 345 babies born to parents using specific gender selection method were boys. Okay, 188 and 345 I already even wrote down here and subtracted. So 157 is smaller one, it's gonna be our x, right? Okay. Use the sign test and 1% significance level to test the claim that the method has no effect on the likelihood of a boy. So let's P, which is proportion, percentage, denote the population proportion of baby boys. Ignore the possibility of the method decreasing the likelihood of boys. So here our choice is gonna be there is no difference. Yes. Where is it? Equals 0.5, which is equally likely, 50-50%. And the claim is that it's going to give you more than a result of it. This is clinical trial, that you can get more boys than girls. Okay, this is going to be our hypothesis test. Next, we need to determine if sample data are really greater than 0.5. Since the sample proportion of boys is greater than 0.5, then the sample data does not contradict to greater than 5. So what we're gonna do, we had, let me see, 188 positive signs and 157 negative. Because why we took this way? Because 188 it's were boys, and it's based on their claim. So clinical trial will help them to get more boys than girls. This is why 188 we mark down as boys, and difference gives us girls. So it's gonna be plus, and minus smaller number is gonna be minus, which means x is gonna be, in this case, x is gonna be 157, the smallest number, smaller between the two, right? So next, our total is 345, correct? N is 345. So since it's greater than 157 is greater than 25, it's a measurement that we can use table for cyan test, and there is no such table. Therefore, that means we are approximating to normal distribution, and that is the reason that there is no cyan rank test, because behind of 25 it's gonna be approximation to normal distribution. Therefore, having x and having n, you can find out the z-score table, and I'm not going to write down again because you have it. I'll just write down formula: x plus 0.5 minus n over 2 divided square root n over 2. So whatever you get, positive or negative, it's most likely it's gonna be negative. You're gonna go to p-value and get your p-value based on a z-score test, right? This z-score test, you're gonna get p-value. Since it's a right tail, our will be a left tail, but it doesn't matter because p-value it's gonna be it's usually the same, right? Left tail or right tail. This is, we're talking about areas. These statistics flip for negative, positive. P-value is an area which is going to be same, okay? And then based on p-value, we're going to reject or fail to reject the null hypothesis and draw the conclusion, okay? So at this point, let me see if I can get this answer completed work. It doesn't show. Let me go back. Number 9. Okay, come back. Number 10. No, it doesn't show. But that's okay, I guess, because you know how to do it. I already explained. And the only thing I would like to stress out, if p-value you get less than significance level, and you are going to use significance level is how many? 1%. If it's less than 1%, then we reject null hypothesis. And accordingly, there is sufficient evidence that the method used will be effective in increasing the likelihood of a boy. Okay, moving to question number 11. What do we have on question number 11 here? So the table below lists the weight of college students in September and late April. So assume we use the Willcoxon rank test to test the claim of no difference between September weight and April weight. What requirement must be satisfied for the test? Is there any requirement that population must have normal distribution or any other specific distribution? In what sense is this Willcoxon rank test is distribution-free test? Okay, in a case of Willcoxon rank test, the only requirement is gonna be that they are going to be, first of all, matched pair, okay, and they are going to be simple random sample, and the population of differences have to have distribution that is approximately symmetric. And there is no requirement for the normal distribution. And this is why we call distribution-free test. So let's see, everything I mentioned, which one is gonna satisfy? Requirement, let's go by A. The only requirement is that matched pairs are simple random sample, and the population of the difference has distribution that is approximately symmetric. There is no requirement of normal distribution of any other specific. It looks like this is A, unless I missed something there. No, I didn't. So we're doing good. Moving to number 12. What do we have in this case? So we are going to figure out, here we have temperature at 8 a.m., temperature at 12 a.m. The data are matched pairs because each pair of temperature is measured from the same person. Okay? Using the data, it is possible to test for no difference between body temperature at 8 and 12 a.m. by using sign test or the Willcoxon sign rank test. In what sense does the Willcoxon sign rank test incorporate and use more information than sign test? Okay, the thing is, and let's make sure, the sign test using only signs of the differences. But the Willcoxon sign rank test, it's gonna use ranks that are affecting by magnitude. Remember, absolute value of the difference. So which one is it? Ranks affecting by the, oh, looks like it's this one. Only the sign of the difference, but the rank test uses ranks, not just ranks, signed ranks. Okay. And the signs of the differences, it's gonna be A. Because which one was that? Sign run tests that are affected by the magnitude of the difference. Is it the same thing? Let me check. A and C. Test uses the only the magnitude. No, this is not right. Uses only the sign of differences. Yeah, I was making wrong choice. Sign of difference, but the sign rank. Okay. Looks like it's C. Good job. Next question. Let me see what it is. Is a non-parametric test that uses ranks. Okay, that's a Willcoxon. I don't even need to continue because it's using ranks. Willcoxon science test. Okay, testing a null hypothesis and blah blah blah. I don't need to continue because among these suggestions only Willcoxon using ranks. Question number 17. Which of the following is not requirement for the Willcoxon science test for the match pairs? This one. Data have normal distribution. There is no such requirement. And the last question. What do we have here? Which is of the following is not the case for the Willcoxon science test? If n is greater than 30, a critical z value is used. That is the case. If n is less than 30, test statistics is used. That is the case. Willcoxon sign rank test uses only the signs of the difference. That is not true, using ranks of the difference. And less than 30, critical t value is used to make decision. Yes, we are good. Okay, I am done.